just kind of going through the control stuff first.
Yeah.
So for basically the majority of the HVAC stuff controls is these two panels. This first one here is kind of your main panel as far as when you're looking for your two front end controllers. There's two SCs here. This one is kind of the brains of the building. This one's basically just a bridge for any extra devices and stuff that wouldn't fit on here. So if for some reason you're having a problem with a whole section of the building communication down, this is a place to go and check first. And the way it's set up is this one does the east side of the building. Link 1 is first floor, link 2 is second floor. And then this one will do the west side of the building. Link 1 is first floor, link 2 is second floor. So if like the west side, second floor is down, this is where to look. So that's the quickest way to, as far as your communication within the building. These controllers here are all for your air handler. All the relays are for your safeties. So if for some reason the air handler isn't running and it says it's a safety trip, this is a quick way to tell which one it is. Anything that is lit up is functioning. If it's not lit up, that's basically what's not functioning for you. So any one of these will hold the air handler off and running at any time.
Is that same with these controls? Like if these lights aren't going, you can tell?
Yeah, I mean, if you ever come up here and there's nothing on one of these, it's dead. That's a huge problem. What you're looking at here is the little dash going up and down tells you that it's functioning correctly. You always want to see that. The next two set of lights on each one of these, those are your comm links. You should always see them flickering. They kind of flicker between green and yellow, but usually the green is so fast you don't see it. So usually you'll see kind of the yellow flickering more than anything. The next group of them is your network connection. These are tied to the network here. So also, if for some reason half your building is missing, you come up here and everything looks good. It could be something with your network that it's not communicating between the two of them, or communicating here out to the network so you can get to it through a workstation. So these will be running, these will be running. These ones here usually won't be doing too much. That's for the extra link that you're not using. Power switch and plugs, don't use this for any power tools. It's only for like a computer or something. You can, I mean, it'll handle it, but if you blow a fuse or take out the breaker, your whole building's going to go bad. So you don't want to mess with it. That's why they put it in here. That's why they put it in the cabinet so it's closed up and no one notices it. But if you need to use a computer and you need power, that's what it's for.
Is that switch, if you switch it off?
You shut it off, it basically kills power to all the transformers and shuts everything off. Also. So, I mean, it's in the panel, but if for some reason you want to do a major reboot, that's all you have to do, shut that off, turn it back on, and everything will get powered back up. Now, all of your VAV boxes and stuff are also powered out of these panels. So when you shut that off, it's literally everything that's a trained control or part of the controls is going to go down on you. The second panel, well, you can switch these out to locks also. Yeah. Second panel, basically the same thing. Majority of your VAV boxes. This is for the penthouse controls, which consists mainly of like this extra like supply span system, some of the random pumps and things like that. Hot water, chill water system. So this is all these pumps, the multi-stack, pretty much anything that has to do with that system, including like the boiler in the other room. So again, kind of the same setup. You want to see your lights flashing, good indication. These should always kind of be flashing in unison. These ones always flashing together. You should always see green on all these. If you do see red, that usually indicates either a problem with the controller, but usually it'll indicate that something in this controller is in a failed state, whether it's an input or like a pump failure or something. So if something isn't right, you come up and you see green light, it indicates at least where possibly your problem is also. Again, same with the switch, no power tools, kill it, everything goes bad. So primarily just leave it alone. Some of the differentials are also located here. These ones are for your flow for your geo, your chill water, your hot water system. So they're just monitoring the supply return temperature and then also the flow rate, calculates out your BTUs and stuff like that. They don't really do anything in the system. They're purely there for like monitoring, but they're on the system. So if someone likes looking at those kind of numbers, they can access all that kind of stuff. But it does give you, you can look through it. It'll give you your flow rate, show you your temperatures on your supply returns, and then your BTUs that it's producing.
So what is this the flow rate? 188
Yep.
gallons per minute.
Gallons per minute.
And that should be pretty constant, or does it vary?
This
or?
will all just kind of vary based on
Demand.
The Geo one. The Geo one will, yeah, I mean, they all based on demand. The Geo one usually fluctuates the most because if the chiller is creating like more hot water than it needs or more chill water, then that flow will change based on what it's dumping out to the field.
Yeah.
The chill water one will vary based on it only serves the air handler chill water valve for the most part. So as that valve opens and closes, you'll see this rate change. It does do like the blower coils and like the Liniac, but that's a lot less flow. So primarily that kind of creates the change. And then the hot water is basically just driven off of VAB hot water demand. So they will all change. Not too often you'll see them like set. Once your building kind of gets occupied and the load settles down and all that, these may not vary very much, other than seasonal. So that's basically the wall here for all the controls. Questions?
All stuff you've seen before?
Yeah, I mean the equipment they pretty much see. This is like the newer line of controls. They've had some of these in the other buildings, but this one's definitely loaded up with quite a bit of it.
1-800 call it green. It goes wrong.
He's in my dial. He's in my phone and all that stuff.
So we'll kind of walk through the air handler then. Air handler starts supply fan section. There's 4 supply fans, 4 drives. Each fan has an individual drive, but they're all controlled as like one big fan. So on your graphic, if you look at it, there's only one like start-stop for it. So it's turning all of them on, one speed control. But you do have individual status and failures for each fan. So if like fan number 3 fails, you'll get a failure that fan is the one that's not functioning. The rest will continue running, making up the difference. Big thing to know, because there is 4 of them, is if one of them fails out, it'll actually start spinning backwards, which causes your differential and stuff to drop, and it'll just start circulating air here. So it's a good thing to correct the problem as soon as you can. The building will still probably run okay, but you might see a slowdown in the air supply. So, thing to remember.
Is there an alarm like on your building automation system? Does John get like a text message if that goes down?
On the automation system, they would see that it would say supply fan number 3 failure.
Yeah.
It can email out and all that if that's what they want set up. It's there to do it if they want to.
Yeah.
We haven't done too much of that because usually there's someone kind of monitoring it somewhere. But we can do all the alarming and text messaging and all that kind of stuff if necessary.
Did you guys?
We've never set it up because power plant monitors it 24/7,
Okay.
and then the hospital guys have access to it 24/7 too.
Okay.
So between the two things, we're kind of covered.
Yeah.
And this is tied into like the ensemble system also, which is like all the Gunderson sites. So they'll see these alarms come through whether someone's looking at this site in particular or not. It'll still show up on that alarm log. So several different ways that they're going to know that there's a problem. So supply fan is a UV light system. It's not turned on right now, but basically anytime the air handler is running, the UV light section will also be functioning. It's basically just the section right in here. It does have the ones where it's like the filter bank style. So it's kind of a filter and the UV light kind of in one. As we go through this, your outdoor flow sensor is also here, even though it's actually wired up into the ductwork up on top. This here is what you're using for monitoring how much outside air you're bringing. Lights for the inside of the unit if you ever want to look inside. And you can see like the 4 fan section. It's clean.
So I know when we did the financing, we built at least one, if not more, block-off plates, so that if we have a fan motor fail, we can slide a block-off plate inside.
I
The
don't
idea-
know if you could do that. Well, for one, you can't get in there. And it's actually right here. So this side of it, if you look at here, this side is like the fan side of it. So the inlet side is actually like here, but you UV light sections here. So there's no way to really do that. That's why I say if you have a fan down, it's a good thing to find out what's wrong with it because it will just sit and spin backwards and create somewhat a problem. But
Understand this building's only occupied 9 to 5, where the hospital is 24 hours, so you can wait to right?
Yeah, the whole idea is if you lose a fan motor and it's going to take a week,
To get it.
you can block that one off so air doesn't try to go the wrong way.
Now I understand. Yeah.
the other thing you could do in that situation would be to somehow try to block off the fan so it just can't spin. Because even if you shut the drive off, just the air pulling through it's going to cause it to spin. So, and I have seen that on one of these already. It still produces enough air to supply the building, but you'll definitely know that it's not functioning like it should. Because these will pretty much run at like 100% then, where normally they're around, maybe 50, 60 hertz. They'll be at 100, trying to make up for that when running the wrong direction.
What's the UV light on? When do we want to do the final filter change, the turnover? We're probably ready now-ish, right? Or do you want to do it right before first day?
Ideally, yeah, since we're still going to be doing a lot of
Unpacking,
moving around and unpacking. Yeah, if we could wait until August sometime, that would be great for the final filter change.
Okay.
And the UV lights, same thing could apply. All you're doing is burning up UV light if it's turned on. So I mean,
Yeah.
if it could be mid-August or closer to move-in.
Mm-hmm. 26 is first station, right? So I just put 820 as a note.
I mean, the fan itself is here.
Oh, I
So it's just the inlet side, like John was talking. Some of them, where you can actually access that side, they have a plate you can put over to block off the entry. But
What do you do, like, what's a broom handle or something?
that's
in there?
except what you can do is cram a block or something in there and try to keep it from spinning like that. It's about all you can really do.
These motors have grease fittings, Jim?
Potentially. Yeah. I think it might be something that we do in conjunction with the hospital. They're overseeing to let them see the whole works at once. I don't know, but yeah. I'm not one of the. I'm a member of OEA, but I'm not necessarily one of the board members or anything like that.
These are down here, might as well hit this too. Your high limit. So for some reason you got fire smoke damper, something that closes that causes your duct pressure to jump real quick. This will trip out and shut the unit down too. But again, it'll trigger, one of those relays will go off, and you'll also get an alarm that says your high limit's tripped. So resetting on this is pushing the white button. So same thing you have on a lot of the other ones, but that's where it's located. So UV lights, yeah, if you want to turn them on, it's as simple as just throwing that disconnect, and then it'll just turn on and off as the air handler's turning on and off. So no big deal on that.
Assuming that the door's interlocked, if you open a door.
This whole section here is what it is. There is a little window at the top, and you'll see that it's on through that all the time.
You've tested it, does it work?
Yeah, we can turn it on even right now. It doesn't matter. It's as simple as just turning it on. So chill water section. This has 2 free stats on it. So there's one here. There's another one way at the top. So each one of those just kind of covers one section of the coil. So again, free stat trips. That's when you want to reset it. You got a little door so you can get in that section at least.
So that's if the coils are getting too cold or clogged, it'll...
It's mainly for like during the winter. So
Okay.
if we're bringing outside air and it's like 0 and it gets too cold in here for some reason, say your hot water valve fails or something, below 35, those will just trip and shut the unit off.
Okay.
So
Protecting the coil.
until someone hits the reset on there, it just won't run.
Okay.
So, and then the hot water coil section does have a little coil pump that'll run anytime it's below 40 degrees out. This pump will just circulate water through the coil at all times. Also, when the air handle is shut off and it's below 40, the valve will stay wide open, circulating hot water through it all the time. So this is just grease protection again. So if this fails, and you bring any cold air, it'll just keep water circulating, trying to keep the coil from freezing. But left, eventually,
So right now there wouldn't be. This is not active at all, right? Because it's outside air is 70 degrees.
Right. Yeah. Yeah.
Okay.
Yeah, they'll kind of switch over. Right now it's like 50 degrees is a switch over. So above 50, we use chill water. Below 50, you're kind of switched over to
Reheating.
hot water
Yeah.
kind of thing.
Right nighttime, this is running right now, and then daytime, we're cooling the water there. Because it's always leaving the air handler at 55 degrees or thereabouts.
Thereabouts, it does actually, there's a reset schedule that's associated with it, so it's just whatever the temperature is outside is what it is discharging at the time. So like during the winter, primarily it'll be putting out more like 70, but if it needs cooling, it'll go down to the 55. So we'll kind of fluctuate between those two.
Okay, so it doesn't make the VAVs work as hard during the...
Right,
Okay.
so like during the summer, you're looking for a lot of cooling. You're already given 55, so you shouldn't have to do anything. And during the winter, the VAVs still primarily do the heating because it's per space.
Yeah.
So if there's no spaces that are requiring cooling, then the air handler will start providing heat.
Okay.
If the air handler is there always to provide cooling for any one spot that needs cooling, it'll do cooling, and then the VAVs will all reheat to
Yeah.
control their own individual temperatures.
Okay.
So hot water stuff, filter differentials are here. Again, I know you guys primarily change like on a scheduled time or something, but you can monitor these. It is on the system and see maybe at what point, what is your differential when you decide to change them. You can kind of record that, and then maybe you don't have to change them as often or something, but they're there for your use. And filter sections just in here. Then kind of from about here down is all the return section. Return dampers, outdoor damper, relief dampers are all in this section too. You can kind of, if you look through the window here, you can kind of see the two of them. The outside you can't see just because it's on the other side of the wall. But also your return fans, your return plenum differential. Again, primarily there for monitoring, but if for some reason, say like these dampers are both closed at the same time and this differential shoots up, it will shut the return fan down. And from the graphic, there's a point that you can reset that to get this all back running again. So for some reason your actuators fail and these are both sitting closed, this will shut this section down. As far as the high side, and then there is also a suction side for the return limit also, so it's like a low limit, same as the high limit for the supply. So if for some reason this side can't pull any air from someplace, this will go negative and shut this section down too. So the whole, this one and that one and the one there will shut the whole unit down if it can't have someplace to receive or supply air.
Notice the boxes are over there, so we can look and see if these guys might know what filters actually go in there.
Yeah, it's some of the big ones.
Okay.
And like just a regular plate tubes.
I guess those are both sizes. So that we know what.
Number of ones are reading.
Oh, right on there or whatever. It's either that or in the OMs.
Do you know what a good filter differential is? Like right now it says 0.29 on one side and 0.45 on the other.
Yeah, a lot of it just depends on when you're looking at your filters.
Yeah.
Some people, like say, you could determine at what point you're going to switch your filters,
Yeah.
and then record what that is, and then you kind of know when you
Okay.
want to switch your filters.
Yeah.
But sometimes it's a little deceiving too, because like the one side of it is on like the suction side, the other side's on the like the leaving side of it. So some filters will have just produce a higher differential across them to start with. So that, you know, kind of is where you got to start with the number,
Okay.
and then like I say, based on either annual change or look at the light change, you can kind of determine where you might want to change that. So,
Okay.
and if you say, well, like at 3 inches I want to change them, you can actually set up an alarm on those that says when it's on 3 inches, it says, hey, I'm at 3 inches, and then you know to change it. So.
Makes sense to do that just so just in case outside of your PM, you know, you had anomaly where like you know, Cottonwood released all its stuff and now you got
Yep. So there's 2-inch and 4-inch filters in here.
So that's basically the air handler, unless someone's got questions.
and I think we bought these filters, right? for construction use, and then you guys provide one set for final use. Do you also provide a spare set on top of that, or is that something you want us to buy? So you just have final. Okay.
Um,
Or do you have enough in your system you don't need?
well, I mean, we order specifically for this clinic,
Okay.
and we'd probably keep a set on hand in case something happens. We like to have them on hand.
Yeah.
They get wet or get damaged somehow. So ideally, yeah, if we could. So I heard you say, yeah, like there it says it's all the same size filters, but it's not. Well, if we could get a list of, yeah, there's 20 by 20s and whatever. If we can get a list of something to that effect, it helps us.
Yeah,
You know,
ordering stuff.
Yeah.
Yeah, I'll just get a hold of Rob Jordan and you'll be able to look that up real easy and just give me everything that you
Even
need.
if you want, usually just write it right on the door there.
Yeah, you know, because they're in the O&Ms, but they're,
yeah,
if it's from any other one, they're not that easy to find.
and if
Yeah.
it's like that,
Send you like a submittal because it'll tell you right in there.
Yeah, we
What
got
they
them in the
are.
O&Ms, but, you know, I'll just have Rob just, he can look it up real quick and print it right off.
Cooley was the first one to turn in their own M. You were the last. Mechanical Contractor was the biggest book, but you guys got this in really early.
Bridget's in charge of that.
Yeah.
As soon as submittals are
Done.
approved, she puts an order in for O&Ms.
Good job on her. Yeah.
They take a while.
And for our O&M too, that you'll have anyways, but if you want, we can actually get in like a CD for you too. So if there's anyone who just wants one
I think there was
to have on themselves.
Was there PDFs and stuff?
Yeah, they're all in PDF form, but I can just get you actually a CD so you don't have to carry the book, paperwork part of it around with you or something. And it is, PDF, so you can put it on your phone and just save it there, and then you'll have it with you too. So, but yeah, that's the air handler. Questions? Same old, same old.
You want to cover just the general function of this,
Yeah,
or
we'll just do a rundown quick of this whole thing. So, we'll start down here and work our way back. So for your hot water, chill water system, it's kind of like Sparta where you have geo pumps, but here you also have hot water pumps and chill water pumps. There's two of each pump style, so they're lead lag and redundant on each other. Once a week they'll rotate, or on a failure of the lead pump, the lag pump will turn on and run. So kind of like what you normally see. Drives, the two down there are the geos, and they're kind of listed on, but you have hot water pumps and chill water pumps. So same drives kind of situation. So if you have a pump that isn't running, the drives have alarms that will generate from it if it fails out, or if the drive itself is in failure, you'll get an alarm. They all run off of differentials. Most of them are the ones that are up here. So you got your chill water differential that's controlling kind of the chill water side that's going to, now these are all what's entering or leaving the multi-stack. So chill water differential to the multi-stack, hot water differential. And then the Geo one kind of hanging down from the corner here. So it's the one straight back on the wall. And they're all set up, and if you look at your graphic, there is set points that these are all controlling to and everything. Primarily set up by the multi-stack guy, what he needed for differential across the multi-stack to have it function the way they want it. So I wouldn't change them too much. Yeah, we'll just leave it at that. I just see that if you don't need to change them, just leave them there. But you can see what they're supposed to be and then what the reading is that you're getting from it. The multi-stack itself, it's running in what they call a simultaneous mode. So it's looking to make chill water and hot water at the same time, but it bases it on whichever one of those has a higher demand. So if they have a high demand, like say this summer where you're looking to produce a lot of chill water, well, it's also creating hot water. The hot water that this supplies out is 120 degrees, so if it starts making water excessive to that 120, there's actual, for each of the sections, there's like a bypass or like a mixing valve that'll start open, and it'll start dumping water actually to the geofield. So like during the summer, it wouldn't be surprising to see the geofield with a really high flow, and the water temperature could be like 100 degrees or something like that. And you may be going like, what's that all about? But it's the excessive water, that hot water that this is producing, that it's dumping out to the field, while it's trying to create the chill water that it needs. And then during the winter, you'd see just the opposite. You might be creating your 120, but by doing that, you're creating an excess of chilled water. So you might see water leaving to the geofield that's at like 35 degrees. So again, and it could be at a high flow rate, which is really deceiving, because you can have like 1 million BTUs of chill water dumping down to your field. But you're wondering, well, that's kind of a waste. But you're actually, it's there because it's creating a lot more hot water that's necessary for the building. So when you're looking at the whole graphic for this whole system, you'll see those flows and everything and the BTUs. And sometimes when you're looking at it, it looks really incorrect, but it's doing what it's supposed to do.
So this summer the field gets warmer, in the winter it gets cooler.
Basically. Yeah, so during the summer, like say you're looking to cool your building, you're producing chill water, so that excessive hot water that the building doesn't need is just getting dumped to the field. And it could be 120 degrees for all you know. And then during the summer or winter, when it rolls around, then you're actually producing a lot of hot water. It is pulling back some of that water that's now warm from the field, which actually helps it run. But you might see that field water coming back at like 45 degrees. You know, so it's just weird the way it works, but that is what it's supposed to be doing. So these will do both. They actually have it set up, I believe, like the first 3 sections are primarily for heating, and the last 2 are primarily for cooling, but it will do all heating and all cooling. But in simultaneous, those are the ones that it'll trigger. Like if it needs heating, it'll start with like number 1, but if it needs cooling too, it might start with number 3 or 4 or something like that.
And you're fed from both sides then.
Yeah, like you'll have the chill water side is going through, the hot water side is going through at the same time, and then the third pipe is out to the geofield, and the mixing valves and to kind of determine where it might dump hot water, chilled water, both hot and chilled can go at the same time, whatever it needs to do to maintain the temperatures that it's supposed to be supplying out.
It's pretty cool.
Yeah.
You guys have them all over the place.
Yeah, so inside of here, I mean, there's a lot of valves and stuff going on that hopefully you'll never really have to get to because they're not the easiest things, but but all the controls and everything for it, I know like if you take up the panels on this side of it, that's where all the panels are for all the controls. This side is basically just kind of get access to the compressors and things like that. So that's all I know about that. So pretty much it's just water circulating through this thing. It's either heating it up, cooling it down, and throwing it back into the building.
So if you want to look at the intakes, you saw the intakes on either side for the cold air and exhaust, right? Or fresh air. You know where they are on the roof.
I have no.
We can walk out there and look at them. But
So the filters laying on top there, are they for this? For the multi-stack? Those Bowman filters?
Dave, do you have any idea what these are?
Right here,
Oh,
Dave.
these filters right here. These, I don't know where these came from, but they were shipped. If somebody shipped them wrong or what, but your filter over there only is about that high, or like that. That's all it was. We put the filters that came with that. I don't know if they got this mixed up or something when they ordered it or what, but you have your filters in that bag right there.
I'll find out. Okay.
So is there a filter top there too?
Is there filters on this?
So
Yeah,
there
there's a
filter
strainer.
pot- strainer
There's a
there, too?
strainer here. There's a strainer here. And there's a strainer on both sides of those. We put drain valves. All you got to do is pop the top off here, shut everything down, which your valves are right here. And you just loosen that up, and there's a basket strainer right in there. You can just pull right out
Okay.
if you got problems.
Right.
They're on both sides of the returns.
Okay.
Yeah, them came with that. I don't know what they were. They came with what? All the stuff from fluid handling. So I don't know if they got shipped wrong or they got. Yeah, there's one.
often should you check those, you think?
I'd say every 2 months, pull one out, shut it down, shut the valves off, pull it out, see what it is, see what's in there. But the biggest thing is, all this, you guys know it's all glycol. The whole system's glycol. Everything's glycol. So you gotta, that's why I got the drain valve down. Once you reclaim it, you take it like this, put everything back. And this over here is your makeup. You just take it back here. And this is already preset, or what is it? I think 12 pounds it's set at right now. So if this gets down below 12 pounds, this little pump will already kick on. That's your alarms and everything for this. So when you get down below whatever you got in here, it'll send off alarm. You got to add more glycol to it. But this is all set. It'll just do what it's got to do. If you lose glycol, it'll keep pumping. But if you need to add or like say you drain down a pump or something, just come over here, undo that, pour it right in there, reclaim it. And that's your relief valves. That'll blow down into there if you ever have any problems. And this is your strainer. That's what them filters were, them big long ones, but they're short ones in there. So all you gotta do is shut that down, bleed it down, pull the basket out, pull whatever. And I'd say do that every 2 months to check that. See what's the matter with it. But yeah, everything's pretty much, it does it by itself. If it goes down, it'll kick it right back up to 12 pounds.
And this shouldn't ever get full unless there's some bypass event, right?
This should never ever go off. Never ever go off. Never ever go off. We just had it go off because when the tanker truck was out here, he was just pouring the glycol to it, and then I just started popping them off. But no, otherwise, the valves over here, these are.
Once you shut this down,
Yep.
you said shut it down here and bleed it off. That excess, do we just pour it back
Yep.
into the?
Yep. Just undo that, take your holes and whatever, shut where the valves are. It should be. Oh, here's a valve there.
Shut
Take a
both?
hose, you got a bleeder there, open it up, take a bucket and drop it in there.
Yeah.
And you take that off, leave them off, and they're just cartridges, that's all they are.
Shorter than like the ones over
Yeah,
here. And then
yeah.
just take that excess and just dump it back in
Take
there.
it right in there and just dump it right back in there, you're good to go. If you got any problems with glycol, or if you reclaim it, if you got it in a bucket, just take it right there and put it in there. So you save it.
Yes. Okay.
The buffer tank, that's just for more capacity. That's all that does. More capacity. If anything, you add on or whatever, you got more. But the valves are right here. You guys can see that you got valves here.
That's an offline filter. So you can do that. You don't have to shut pumps off
Nope.
or anything.
Nope.
You know, I did at any time.
Anytime.
Every 2 months.
Anytime. Because it's just, you ain't causing no problems. You ain't deadheading the pumps or nothing. And these over here, these are your valves for your heating homes or whatever. This right here is your geo. That's coming down out in that corner where the break room is. So if you shut these off, make sure the pumps are down. Make sure if you got problems up here, these two right here only take care of what's ever here. What's ever here. You've got, I'll show you later, you got valves where that comes up through the ground. That'll take care of from the ground up to here. If you ever have problems on second or first or second, then we'll take care of that. These, chilled water return, these, if you shut these off right here, right now, these go down and they run halfway, split the building in half. They run down and they pick up a blower coil on second. They turn, they go down a chase, and then they go to your LINAC, your linear accelerator. They go to blower coils and everything. These are the valves that'll kill that. All your chilled water, all the stuff that you got with chilled water is on this side of the building. There is nothing over there, nothing. Let's see, these are the heating. They showed the heating down on second, but with all the cluster in that, there's one on the back side right here. Yeah, right here. There's two of them right here. This heating right here will kill first and second floor, the half. Split the building in half, that half, it'll kill. You got other valves that'll kill that side, and all that. If you shut these off, it'll kill that half. And that's...
Are the valves for that half up here too? or-
Nope. These lines go down and then we split off. We came off this, and then they go like this. Then they go down, which the valves are down on first for that half. Yeah, yep. And then these are hot water. This is for your backup boiler right here. You got 2 valves there. If you shut these 2 valves off, it'll kill everything there. But these come over. These 2 lines come over. This is your heating that supplies would be this side. This side. They just split them in half. They just split this whole thing in half. If you look at the print, you see I got them stickers up there. But these 2 go down. These 2 go down, and then they go. Where's this valve off at? That's down on second. I marked it for you guys. So if you shut those off.
Did you mark this one over here so we know which side we look at?
Yes. Everything's marked. But I can take you down on second and show you where all the valves are. So if you want to isolate each zone, if you guys got problems, you can just shut the thing off and all that. And I can show you where the geo loop is, where you can shut that off. So if you got problems from ground up to here, that'll kill everything. They came down, I forgot what chase it was. It was a chase, I think it was right in there. They came down, they split, and then went down to first to feed this side again.
And are there isolation valves
Down on first to
go that way and to go that way?
Yep.
Okay.
So I can take you guys over to these other ones. And if you have any problems where the edge of the air handler was, the end of the air handler, you'd see 2 hot water lines that went over and then went behind the air handler. There's 2 valves right here to kill this area, and it goes to halfway to the elevator. That'll just take this area, and then there's separate valves for each zone.
Okay. All right. And that's all denoted on a plan
Yes,
somewhere?
yes. Yep. And they can go down to first, and I can show you where them valves are all down there too.
You ever lunch nowadays? You're a slave driver.
I wanna go, I got stuff to do. I gotta get my trailer hooked up and
Where are you going next?
Toma VA.
Oh yeah?
Yep. This would be the easiest. We'll go down here. Them last valves that we looked at up there, them are the lines, they come down all the way down the hallway, and then they turn, they come in, they come down. Right where that dot is, what it showed on the plan, is just have two 2-inch ball valves.
Yep.
You kill those, if you just kill those, you're just gonna kill this part half, and this goes down around there and picks up that
First floor.
first floor, that'll
Yep.
kill that.
All right.
So if you shut those two, that'll just kill this half and everything else will be running.
All right.
And now across the floor here, we got some, where that 3-inch comes down from the boiler. That's right here. Right there it is. There, right there. So then, where the boiler room was, up above where we came down,
Yep.
this is the chase that they came in.
All right.
They come out, and there's an 1.5 that goes that way, which, right there, 2.5 valves.
Yep.
And there's a 3/4 that goes around and comes into that other hallway. If you got any problems, there's a pair of 3/4 right there, so you shut. But if you guys got any problems and you just wanna shut the whole side off, just shut them 3-inch, or them 3-inch on first floor, and then but the pumps will still be running, cause you won't have no deadhead or nothing.
All right.
And then if you wanna go down here where these other ones are on this side. These ones come down right here. It's the hot water and the chilled water. They come down, they split. So half of the hot water and chilled water are going that way, half of the hot water and chilled water are going that way. The valves for each one are right there, hot water and chilled water. So if you want to kill this side, go right there, you'll see the T going that way, which it'll kill your linear accelerator too. And all that stuff, that and down there. If you got problems with blower coils or whatever, because you got a blower coil, yeah, right in there, and 2 down there, in where that linear accelerator is. But that, yeah, it just comes down and splits, and then you got separate valves for each zone. And that should be less up for the Linac.
Let's go look at the Linac room after we're done.
Slave drive, Ryan.
Yep.
This is your chill water coming in, return, everything right there. That's coming off from your multi-stack and everything. This is going to your linear accelerator over in that room. Right now, you're at 66.6 degrees. They said maintain about 68 or whatever, but we put it at 66. It fluctuates. It's been working fine. 85 degrees, when it reaches over 85 degrees, the temperature, that's when your city water will kick on. It'll pop on. This does it all internally. Once that does it, this recognizes what's going on, and it'll kick it on, convert it over to city water. If you got a power outage or whatever, it'll kick it over because your temperature's going up, it'll kick on. But once this thing switches over to city water, what the Filtron guy said, you've got to come back to this unit, turn this to off, the switch, and turn it right back to manual. Then when everything's running, it'll go right back to chilled water supply. And then your chiller will be cooling instead of dumping your city water. And your filters are right there, I set them. But get in here for your water. There's a wrench. See, if you see that in there, there's the flat plate heat exchanger. There's one in there right there when it switches over. But when you want to change the filter, you guys know this, just open that up, shut that off. You're still in running mode. It's bypassing this. You got a wrench and seals and everything. Take that off, then turn it right back on where it is. But otherwise, that's pretty much what I know about this thing. Back in there. There we go.
I don't know for sure if that'll be us changing that filter or if clinical engineering will do that because it's tied to the. I don't know. We'll have to cross that bridge, but.
And that's pretty much it.
You're done?
So Jim,
While you're, I was gonna say, while you're back here too, the panel that does, this is one of the other panels that stuck in the Linux accelerator, and all we're doing is monitoring points off of that, so there is no outputs or anything to it, here are the inputs. The other one is for like the domestic water heat exchanger and stuff in the other room. So if you're looking for these controls, that's where they're at. And then the two blower coils, one blower coil for each of the vaults, I guess as they call them.
Yep.
There is a VAV that supplies fresh air into those two, into the return of the heat, or of the blower coil, and then that gets pulled into the blower coil unit. So there is a VAV. If you look up, there's a VAV tied into each one of them also. But the VAVs, even if you unoccupy those, like you unoccupy the space, it'll close the VAVs down, but these heat pumps will always stay running all the time for the rooms. So
one of the transformers for.
transformers in here. One is these are probably for more of the VAVs out like on this section. Like I said, all of our VAVs are also tied to these panels. The power is. So if you're looking for any transformers for them, there's some here. The ones upstairs, and then on the second floor, I probably should have showed you that. But like behind that, the desk up there, I don't know what the room is called. It's like on the other side of the hallway from there. There's another one of our panels that does like the destratification fans and everything. There's another bank of transformers in that panel also for the VAVs. So.
Just radiant panels, is that the boards in them? Are there boards in
No,
them?
they're all tied to our controls somewhere, and they run off a local thermostat that's in that area. So.
I can show you the locations. Yeah, because there's some in Reno as well.
So it's just got a hot water valve in the cabinet, and that's pulled back or someplace.
Yeah, like
in the
most of them
ceiling,
are
maybe.
like in the ceiling close by, and they'll, like I said, if they're associated like with a space with a VAV, it'll use the VAV one. If there's no VAV or like the ones that are on the walls and stuff out front, they'll just have a stat on the wall that triggers them off of the set point off your graphic. So you can see all that on there too. So.
No, I think
Not
we're
much.
good. Any of that? Okay.
I'll show you where they are because there's some in some bathrooms and there's also one in the link, so I can show you the locations. VAV boxes, you guys know what we'll just have to label them. Heat exchanger we went through. Geothermal heat exchanger, multi-stack, we looked at that. HVAC pumps, just those 6 up in the penthouse. And then looks like there's some recirc ones, is that for?
No, those aren't ours. The only other ones we have is the domestic stuff.
Okay.
That's it. And that boiler one.
Suppose those are probably for the water going to the linen.
Yeah.
Is that, there's a pump up there, right? Am I not
Yeah, I think
right?
that's.
Yeah.
I think that's what feeds from here to the Liniacs in there.
Okay.
Because we don't feed them. We just feed
Oh, I think
this.
the pumps are
And
there.
then this feeds out.
Okay. That's a $60,000 unit that heat exchanger is, so. We do buy you nice stuff sometimes.
There you go.
Boilers and chillers we talked about. Then general preventative maintenance. You guys have your own PM schedule. Is there anything else that's special to this that you need to have preventative maintenance questions? I mean, you can read through the O&Ms, but that's up there.
We have a multi-stacks.
Right. I don't think so. If you think
anything that you have questions about?
Pumps that are taken out. We got the regulars.
Um, I guess I can't think of anything. You know, there's nothing we don't already have elsewhere.
Right.
You know, with the exception of a couple questions about like what that thing does when it goes into city water backup and then that caulk business up on second floor. That would definitely
Down here too, what the maintenance on that.
door. Oh, the door. Yeah.
The only other thing that we just thought of is the main geo loop shut-off
The
valves.
valves,
the shut-off
We actually
Did you see
earlier
them?
before we saw
Okay.
you guys.
You've seen 'em.
Yeah, because we saw them on a walkthrough, so then we walked over there and made sure everybody
That's
saw
your
them.
loop right there,
Yeah.
and then you got the bypass there and everything's right there.
So the only thing we didn't do is you had mentioned going out into the parking lot and actually opening the.
I don't know if it's a manhole cover. I don't think I can
Oh.
get it off.
That's not. That's fine. That's not necessary.
It's big tank it down. But we can go and take a look at it and see if we
If,
You're stronger than I am.
I guess if we even just if you just show us where it is,
Yeah.
that'd probably be all. Odds are we aren't going down in there either,
Yep.
but at least that way we know where it is.
If you see a big sinkhole in your parking lot, you know what the issue is.
I have your cell number.
But that happened in Sparta.
Really?
That one of the wells broke and
Oh.
yeah.